Hello everybody. Today I would like to share with you how lens formula is derived. How lens formula is derived. So let us consider a point object lying on the principal axis of the lens. Point object lying here on the principal axis, let's call it O. So it sends a ray on the incident ray on the lens in this way. After striking on the lens will be reflected in this way. It deviates. So where the image is formed is here. Also it is found on the principal axis. Here we have what we call deviation angle. Let's call it D. Here we have angle beta, alpha, which the incident ray makes with the principal axis, and here we have angle beta, which is called the angle which reflected ray makes on the principal axis. So by this time the incident ray makes a small head here on the lens, which called H. So we are going to find the tan of the angle alpha. The distance from the point object to the lens is called the object distance U, and the distance from the lens to the image is called the image distance V. So first let us find the tan of angle alpha, which is equal to the opposite side H over adjacent side, which is U. And again, let's also find the tan of beta, which is equal to opposite side also H over V. By this way, this deviation angle, it is a stereo angle, and it is equal to the sum of interior angle of this triangle, or P and I. So this means that D is equal to the sum of interior angle alpha plus beta. Also we have to consider that if alpha and beta is small angle, mean that tan alpha will be approximately to alpha, and tan beta also is approximately to beta. Mean that alpha is approximately equal to H over U, and beta is approximately to H over V. So this is equation number 2. This is equation number 3. Then put 2 and 3 in 1. We found that deviation angle is equal to H over U plus H over V. So this equation number 4 is important in this deriving of lens formula. So second, this is the first case. This one is the first case. It is case 1. What about case number 2? We have to consider in this session. Case number 2, we have also to consider object when is located at infinite. When a point object is located at infinite, what will happen? This lens is a converging lens. It is not concave lens, because remember the sign. of the lens. So for when the object is at infinite, it sends parallel rays to the principal axis, strikes on the lens, and after striking on the lens will be reflected through the focal point, as I said in the role of trace of forming image. So here it is the focal point. The distance from focal point to the lens is called focal length. So here also it makes the same head as the first case does. Here also you have angle, let's call it phi, and here we have deviation angle, which is the same as the first case. So by the way, this D and this phi are the alternative angle. Since it is alternative angle, it means that D is the same as phi. It is the equal. And how we find phi? We have to use sin phi is equal to the opposite side, which is head, over adjacent side, which is focal length. So for small angle, for small phi, tan phi approximately to phi. So mean that phi is equal to the approximate equal to h over f, which is focal length. And remember, phi is equal to the deviation angle. Mean that deviation angle on the second case is equal to h over f. This is second case. And this equation, call it equation number 5. Equation number 5. So these two equations, the great important thing are there, it is deviation. And this deviation on the first case and second case are the same. It means that in order to find the lens maker, the lens formula, we have to equalize these two equations. Equalize equation number 4 and equation number 5. So remember that equation number 4 is look at here, it is D, which is equal to h over u plus h over v, which is equal to the equation number 5, which is f over f. Right? Yes. So if you look well, we have h, yes. We can divide it by h on both sides in order to simplify h. So when you divide here by h, we remain by h over u divided by 1 over h plus h over v divided by 1 over h, which is equal to h over f divided by 1 over h multiply. Okay, this can be simplified, this, and this, and we remain with 1 over u plus 1 over v, which is equal to 1 over f. So this is a great important equation. This is a great important equation here in the optics, where this u is the object distance, v is the image distance, and f is the focal length. So this is the session for today, and on the next session I will discuss on sign conversion of these operators for this formula. When U is positive, when V is positive or negative, and when F is positive or negative. We will discuss on the next session or next video. Thank you for seeing or viewing this, and remember that today we are not at school, but you have to use our opportunity you have in order to increase our knowledge using ICT in education. So remember, don't forget to subscribe the video. Thank you. See you next video. Thank you.